Hello everyone, this is Jajsuda from Srivasavi Engineering College. I'm working as the assistant professor in EEE department. Today I want to give you a little lecture about switchgear and protection. What is meant by switchgear? Generally, switchgear is the combination of switches, fuses, controlling circuits, etc. So the switchgear and protection includes the switching, controlling equipment together in power system. So switchgear is a combination of switches which protects the power systems from faults, overcurrents, and which isolates the faulty circuit, which isolates the faulty circuit from the healthy circuit, and it is used to de-energize the equipment and clear the faults. So voltage wise, switchgear categories are generally five types. First one is low voltage switchgear. It is up to 11 kV, and medium voltage switchgear is up to 66 kV, and high voltage switchgear up to 400 kV, and extra high voltage switchgear up to 765 kV. And high voltage DC switchgear is there. That's for DC system. So generally, in switchgear and protection, circuit breaker plays a very important role. Circuit breaker is a device which breaks the circuit when fault occurs. As its name indicates that circuit breaker means which breaks the circuit. Whenever fault occurs, a relay senses the fault and sends signal to the circuit breaker. At that time, circuit breaker instantly breaks the circuit and isolates the faulty circuit from the healthy power system. So relay means which detects the faults and which sends the signal to the circuit breaker. So here there are so many circuit breakers are there, and MCB means miniature circuit breakers also there. So where is this circuit breaker is placed in the power system by adjacent to the relay circuit. Generally, circuit breaker consists of two contacts, one fixed contact and one is moving contact. Before the fault, the two contacts are attached to each other. Whenever fault occurs, the moving contact moves away from the fixed contact. At that time, arc is formed between the two contacts, but we have to interrupt the arc to interrupt the current flow between the two contacts. So generally, initiation of the arc takes place at a high voltage gradient. Whenever before the fault, current flowing between two contacts. Whenever fault occurs, there is a short circuit between two contacts. Whenever the contacts are separated, that current flows in the air where ionization takes place and the arc is formed. We have to interrupt the arc. So to interrupt the arc, whenever arc is formed, there is a current with some voltage. The voltage which appears across the circuit breaker at the time of our circuit interruption, then that voltage is called as arc voltage. The voltage which appears across the waveform at the time of arc is called as arc voltage. We have to interrupt the arc. So there are two ways to interrupt the arc. One is high resistance method and another one is low resistance method. In high resistance method, the resistance of the arc or the length of the arc should be increased to weaken the arc. So that the arc resistance will be increased. Whenever arc resistance is increased, the current flowing between the fixed contact, moving contact will be decreased. Then arc will be extinguished. This high resistance method uses some oil or some pressurized air passing between the two fixed contacts. We can extinguish the arc. Second one is low resistance or current zero interruption. Current zero interruption. Moreover, this high resistance method only used for low voltage AC/DC applications, because we have to maintain certain voltage and certain resistance between the contacts. While maintaining the resistance between two contacts, whenever resistance is increased, whenever arc is extinguished, after that, after some instant, if the high voltage power system is there, then arc includes high voltage. After the instant extinguishment of arc, high voltage appears across the fixed two contacts. So this high resistance method is only used for low voltage applications only. For high voltage applications or for high circuit, we will use this low resistance or current zero interruption. In current zero interruption, there are two methods are there. One is recovery rate theory and second one is energy balance theory. In recovery rate theory, whenever arc placed between the two contacts, there is a wave which is the combination of electrons and ions present in between the fixed contact and moving contact. We have to extinguish the arc by splitting the arc, we have to remove the ions and electrons from the medium. But for this, we have to produce some dielectric material between the two contacts which has high dielectric strength, because whenever dielectric strength of the medium is increases, then that electrons and ions will removed from the air, then deionization takes place. So the restriking, this dielectric strength should be higher than the restriking voltage. The rate at which the dielectric strength of the material should be rate of restriking voltage. At that time only we can interrupt the arc. If we maintain the rate of dielectric strength of the material is less than the rate of restriking voltage, then arc will rises again. So we have to maintain the dielectric strength of the material as high than the restriking voltage. This is about recovery rate theory. Coming to energy balance theory. So here this recovery rate theory and energy balance theory are low resistance methods and also called as current zero interruption. Because why current zero interruption means, in AC the cycle alternative, the current and voltage waveforms are alternative, so it should reaches the zero. So at that instant of zero, at that zero instant we have to interrupt the arc, because at zero instant we can have low current and low voltage and low power. So at that time high resistance will be there. By passing this electric strength, dielectric material which has higher electric strength, we can interrupt the arc. So in case of energy balance theory, so in between the contacts of the circuit breaker, there is a vertical area of the ionization is there, ions are there. So we have to deionize that we have to deionize the total medium. So after current zero interruption, whenever current reaches to zero, voltage is zero, power is zero, and resistance will be reached to infinity. After that current zero interruption, resistance will be increases. But at the time of current zero instant, resistance is infinity, because we have to maintain the resistance low at that time. So for this, to reduce the resistance which in between the two mediums, which is present in the arc, we have to produce some dielectric material, like by pumping pressurized oil or by pumping cool air. Because of this high resistance, more heat is dissipated in between the contacts. The rate at which heat produced is higher than the rate at which the heat dissipated, then arc will remains occur. Whenever the heat at the rate at which heat produced is lower than the rate at which heat dissipated, then we can reduce the heat, then we can extinguish the arc. That is about energy balance theory. These two theories are recovery rate theory and energy balance theory, are both are current zero interruption type. And this arc phenomena occurs in low voltage case and high voltage case also. So here ionization, we use two terms, ionization. So in high resistance in high resistance method, we have to increase the length of the arc to extinguish the arc. So here three methods are there, depends upon the factors. Degree of ionization, the resistance increases with decrease in number of ionized particles. So resistance, whenever resistance increases with decrease in the ionized particles between the contacts, then that is called degree of ionization. Length of the arc means arc resistance increases with the length of the arc, and cross section of the arc resistance increases with the area of cross section of the arc. So degree of ionization is inversely proportional to the ionization particles, length of the arc is directly proportional to the resistance, and cross section of the arc also directly proportional to the resistance. So these three factors affecting the arc. Another one is restriking voltage. Here restriking voltage means at the instant of arc interruption, the system voltage appears across the contacts that includes this transient voltage also. Then that the peak of the voltage is called as restriking voltage. At the instant of arc interruption, the voltage which produced is combined with the system voltage, then transient voltage is called as restriking voltage. And recovery voltage also there. The recovery voltage is the after the arc interruption, after the formation of restriking voltage, the so many oscillations are produced in the AC waveform. Thus oscillated waveform produces some voltage. That voltage is called as the recovery voltage. So that is about restriking voltage and recovery voltage. There is a derivation for restriking voltage and recovery voltage. We will see in the next class.